Hello everyone! Welcome to the 2021 Esri Virtual User Conference, and thank you for joining our presentation entitled ArcGIS GeoPlanner – An Introduction. My name is Ryan Perkle, and I'm joined today with my colleague Eliza Gutierrez-Duer. Let's get started. So first, a quick look at what we'll cover today. First, I'll start with a brief intro of some relevant concepts related to green infrastructure, conservation, and 30 by 30 planning. I'll then introduce you to some resources that are available to help you support your work on these topics. Next, we'll transition into some demos where we'll explore and use these resources as part of a typical conservation planning workflow. This will include an exploration of some relevant data, web apps, and a detailed look at ArcGIS GeoPlanner, which is a natural systems planning and design application led by Eliza. So let's start with a brief overview of concepts related to green infrastructure that are relevant to conservation planning and 30-30 efforts. Green infrastructure is a strategically planned and managed network of open spaces, natural lands, wildlife habitats, parks, and other assets that provide communities with the vital services that enrich and sustain their quality of life. Green infrastructure seeks to situate land development and land conservation together in a way that leverages natural environmental patterns. In so doing, green infrastructure promotes both conservation and smart growth. Green infrastructure planning reorders the traditional land development process by identifying, prioritizing, and protecting the landscape's most valuable assets first, as opposed to after development has already occurred. Even in already developed areas, however, green infrastructure planning can illustrate resources that still need protection and highlight areas that would benefit from rehabilitation. In this way, green infrastructure becomes a viable solution to many of our local and global challenges, including those of the global 30 by 30 movement. So next, let's introduce you to some of these resources that are available to help you with your green infrastructure, conservation, and 30 by 30 work, all of which reside on the Living Atlas of the World. As part of a collaborative partnership with the Green Infrastructure Center out of Charlottesville, Virginia, Esri's Green Infrastructure Initiative is a collection of freely available authoritative geospatial resources, newly generated data, online applications, and downloadable models. These resources were created to help initiate a national vision for green infrastructure planning and to empower and equip local organizations with the tools to support their GI, conservation, and 30 by 30 decision-making efforts. The first piece of the initiative is Esri-derived data. These consist of what we call habitat cores and other complementary data sets, including landscape connectivity. Think of these as being the foundational building blocks of a GI, conservation, or 30 by 30 plan. You'll see some of these data in just a few moments. Second, Esri has compiled some of the most relevant environmental data available from other authoritative sources, such as the federal government, and we've made it easily accessible on the Living Atlas. The purpose here is to ensure that you spend less time looking for data and more time doing your meaningful work. Third, we've made these models that we've used to generate these national data sets freely available so that you can further customize them to derive new versions of the data based on your own needs. And finally, we've compiled a series of freely available web apps that can be used to drive stakeholder engagement and to identify GI assets of value. And I'll show several of those in a few moments as well. So Esri partnered with the GIC to develop these resources because they have decades of experience in helping communities to identify, plan for, and protect their most valuable natural assets. They've also honed a repeatable methodology that, when coupled with ArcGIS, can significantly advance this work. The first step is community goal setting, or the articulation of what the community aims to achieve with their GI, conservation, or 30-30 plan. The second step involves data review, or the identification of geospatial information to help them achieve these goals. Step 3 involves mapping your assets. Think of this as the environmental inventory. Or put another way, if you don't know where something is, you can't protect it. Fourth, the process aims to assess various risks that may be exerted on those assets. And this is critical in helping you to understand where your efforts may be most urgently needed. And fifth, the process focuses on developing opportunities. I really liken this to plan making, whereby blueprints of what you aim to achieve are represented by maps and planning documents. And finally, implementation, whereby you put your plan into action and monitor and manage it for success over time. So it's no coincidence that the process we just covered can be leveraged to support numerous global, national, and local conservation movements. First is the Half Earth Project, led by E.O. Wilson. This campaign calls to protect half of the globe to help stem our current biodiversity crisis and reduce species extinction. At a national level, President Biden recently released an executive order that included a call to 30 by 30 and other specific conservation targets. And preceding Biden, California's 30 by 30 order was issued last fall. In so doing, Governor Newsom established statewide conservation targets of 30% of our lands and waters. And excitingly, ESRI is actively involved in helping the state achieve this vision. So for the remainder of our time, we're going to illustrate how we can support efforts such as these and 30 by 30 in particular. So to do that, we're going to transition into a live demo that illustrates the resources we've covered so far and some new ones that can support this process. We'll start by exploring some data, and then we'll kick off the process with some GI web apps, and then we'll bring it all together in ArcGIS GeoPlanner, a natural systems planning and design application. Let's get started. So now I've transitioned to a web browser, and this is Esri's Green Infrastructure website. I encourage you to visit and explore it at your own pace, but for right now I want to call your attention to this resources section. This is where you can gain access to much of the data we're going to explore here. You'll scroll down and you'll notice a series of themed data carousels upon which you can explore this content. Now, alternatively, you can come to ArcGIS Living Atlas of the world. You can search for green infrastructure and give it a whirl. Once loaded, you'll notice that we have a series of green infrastructure data galleries, app galleries, as well as individual feature layers, image services, and tile layers related to much of the content we're going to take a look at today. So we're actually going to get started with the intact habitat cores. I'm going to quickly open the item page, and you'll notice that it's a complete description of how these data were created, metadata, source information, and everything you need to know to understand this content. You'll notice in the upper right, you have the ability to open it in an online viewer, which we're going to do in just a second, and the ability to share and open in desktop and or pro. So let's actually open in the map viewer. Now I've opened my map and I've added several other GI layers for us to explore, but we're going to start with this layer of intact habitat cores. Those areas are shown here in green, and habitat cores represent areas of natural land cover that are at least 100 acres in size and 200 meters wide. For the continental United States, there are approximately 560,000 of these polygons throughout the country. 90% of them are 3,000 acres in size, and 50% of them are 500 acres in size or less. So to show you these data, I'd actually like to zoom into our neck of the woods near Redlands, in an area around Big Bear Lake. So these cores represent the last remaining large natural areas found throughout the U.S. As such, they represent the foundational building blocks for any GI, conservation, or 30-30 effort. Now, in addition to the footprints of these assets, I also want to call your attention to the rich attribution that they ultimately have. Now, these attributes describe the landscape characteristics that are found within these individual areas. And that's really critical for us in conservation decision making because it allows us to identify these remaining assets that contain the variables that we're potentially interested in protecting. And this attribution will be really critical as part of the process that we're going to look at in just a moment. But before we do that, let's take a look at some of these other data. Next, I want to call your attention to landscape fragments. Landscape fragments are also areas of natural land cover, but they're smaller than the 100-acre size threshold established for the green infrastructure cores. These areas can be really critical for conservation efforts in locations where landscapes are highly transformed and where we're looking at improving additional ecological function. Now, the conservation paradigm of the 21st century really moves beyond protection of isolated islands of habitat. Instead, it tends to focus on landscape connectivity, or the facilitation of species movement amongst these islands of habitat. So to better understand landscape connectivity, we modeled paths of wildlife movement amongst these habitat cores. Here's our results. Habitat connectors, depicted by these orange lines, represent the modeled least cost paths amongst neighboring cores. There's some 1.5 million of these connections across the United States. These connections depict the most efficient route between these neighboring areas and by extension represent possible paths for wildlife movement. Now, in order to model these connections, however, you also need a cost or a permeability surface upon which to model them. I'll show you that here next. The habitat cost surface reflects the relative ease of movement for terrestrial species, taking into account several factors. Areas conducive to movement are shown in green. These are naturally vegetated areas undisturbed by humans. Conversely, developed areas, indicated by these areas in red, are more difficult for species to traverse, and they are then less conducive to species movement. So together with this cost surface, the intact habitat cores, you can then begin to model these connections amongst all of those areas to provide a bit more of a conservation blueprint for what you might be interested in protecting. So next, I'd like to show you a map of the US that I bet you haven't seen before. It's a map that depicts the natural areas based on their connectivity importance, or essentially the number of these orange paths that flow through any one of these connected areas. So to show this, I'll turn off the connectors, I'll turn off the cores, and we're going to look at this data set, intact landscape cores by connectivity importance. I'll zoom out to the nation to show you this really cool map. What we start to see here now are cores in darker green representing areas where more of those paths flowed through them. And you see some amazing patterns throughout the United States. This is saying all else being equal, these areas may be higher conservation priority because they ultimately facilitate landscape connectivity throughout this particular region. So with all this information, you might be wondering how much of it, or at least what parts of it, are protected. To help gain some insights on that, we can explore the Protected Areas Database of the US, or PADD-US. Shown here, areas of green depict lands that are part of the database. And at first glance, you might get the impression, wow, we have lots of protected lands and waters. And in many ways, that's actually true. But all protected areas are not created equal. PADD-US ranks levels of protection based on how restrictive activities on those lands can be. If, for example, we focus only on lands that have a GAP status of 1 or 2, it paints a vastly different picture. And this is important because general consensus is that the level of protection that will ultimately be required to help address biodiversity and climate-related issues is this level of status. So GAP status matters, and it's one of these things that can help us to determine how we're moving towards our conservation targets. So there's one additional data set I'd like to share. It's called MOBI, or the Map of Biodiversity Importance, which was recently completed by NatureServe in collaboration with Esri. This map depicts richness of imperiled species, or the count of how many species are threatened based on current conditions. Areas in bright yellow represent hotspots of imperilment. That's to say, there are a relatively high number of species in trouble in those areas. I'm again drawn to Southern California as I'm noticing that that area is lit up. I'm going to zoom to that area really for the remainder of our time here today. So once here, I'm going to come back to my layers, and I'm going to do a quick check of the level of protection of these areas. And you'll notice that these hotspots, these areas that are most imperiled, actually are currently lacking the protection that's going to be needed in order to save species in that area. That's going to be what we aim to address with this planning process moving forward. So now that we've explored some relevant data as part of our process, let's transition to some apps to explore it further and make sense of it all, and actually move through the process to mapping our important assets. So I'm going to access the app from the web browser, and you can access these apps yourself by going back to the GI website or the GI Apps Gallery in the Living Atlas. Now this is a really interesting one. It allows us to explore this database of large intact habitat cores by filtering that underlying attribution. This allows you to identify cores that include landscape characteristics of interest to you. So let's go back to this area around Big Bear Lake. And you'll notice that we have a series of filters to the right, representing the different themes of attributes available to us. I'm going to ultimately come here to one of these filters to start to make some selections and identify the assets on the screen that contain those variables of interest to us. Let's first select endemic species. I'm going to enter in a value of 10 and apply. And we're going to notice that some of those cores in the landscape go away. They ultimately do not meet my selection criteria. So this shows cores that have at least 10 different species that are endemic or associated with limited habitat unique to this area. Next, let's explore another filter, and in this particular case, let's look at wetlands. Now, in this neck of the woods, this region of the country, wetlands are incredibly rare. So I'm going to apply a very low threshold of about 0.25% area by wetlands. And what you'll notice then are we're left with now large intact habitat cores that have a combination of both endemic species and habitat that contains wetlands. Now, this is really critical because those are two potential variables upon which we can make conservation decisions. So the idea is that we start with many choices. What would we protect in this area? And then as we're applying these various selection criteria, we're able to whittle the choices down to more manageable parts of the landscape that contain those variables of interest to us. Now, I know Eliza is working on a hypothetical plan in this area, so I'd like to share these data with her so that she can use it as part of her work. To do this, I'll click on the Save Filtered Cores. I'm going to enter in a name, in this case Big Bear Endemic Species Cores, and I'm going to click OK. Now you'll notice that the app has alerted me to creating a new item successfully. And because I'm logged into my ArcGIS Online organization, this data is automatically saved to that org. And because Eliza is a member of this organization, I can now share it with her so she can continue on with it in her work. Now I'd like to give Eliza a little bit more information to help her with her plan. So for that, I'm going to hop into another GI app that allows us to place prioritization scores on these cores. And that will help us to identify which of them are the most important. Open this app in my other web browser. I'm going to find the information that I just saved to my organization. You'll notice here it is, my Big Bear Endemic Species Cores. I'm going to load that data. I'll then give it a name, Big Bear cores ranked. And click OK. The app has loaded my data, and now let's explore it. So these cores should look familiar to us, but what should be new are these individual numerical values that are associated with them. Think of this as a prioritization ranking that we're now ascribing to these individual areas. Here, I'm going to apply a different default. You're going to notice that the variables or the characteristics associated with these cores really starts to change. I'm going to update this, and you're going to watch these values now recalculate. So now the scores are dependent on the variables in this level of emphasis that we're placing on this. I'll again put another default just to show you this process. It again then updates, and these values have now changed. Now for our purposes, let's go ahead and maximize biodiversity and wetlands in our areas and create a new prioritization score for those. Now the data is again updated, and now the scores will represent cores that have characteristics that we're interested in protecting. Now again, because this content lives in my ArcGIS Online organization, it's updated, it's shareable, and it's accessible to Eliza to continue working through our planning process by identifying the relevant data, mapping assets, assessing threats, and developing alternative conservation scenarios. So with that, Eliza, take it away. It's all yours.
Thanks, Ryan. Now, before we jump into a walkthrough and demo of GeoPlanner, I want to first give an overview of the product. GeoPlanner is a purpose-built application for natural and conservation planning. GeoPlanner empowers you to iteratively analyze, design, and evaluate scenarios in a collaborative environment. You're able to run spatial analysis, design and compare scenarios, and share data-informed plans using dashboards and indicators to better understand project suitability, performance, and impact. Now, picking up where Ryan left off, I'll switch to GeoPlanner, where we will continue reviewing and analyzing data layers before moving on to designing scenarios and evaluating performance for conservation planning in the Bear Creek watershed. So here we are in ArcGIS GeoPlanner. Once you create a project, this is the general interface that you will see. You have your project settings in the upper left, as well as your scenario menu, where you can access existing scenarios, create new ones, or edit existing. The general flow of GeoPlanner is organized into three main tabs: Explore, Design, and Evaluate. We'll move through these tabs in this demo. Additionally, we have our table of contents, where we have our design layers and data layers, as well as our general map view. As an example, here's that richness of imperiled species in the United States taken from our MOBI layer that Ryan showed. You'll recall from Ryan's demo, he highlighted the Bear Creek region as a hotspot for species imperilment. We're going to focus more on this area in Southern California, but before we zoom to that location, let's take a look at the surrounding area. The Bear Creek watershed is located in San Bernardino County. San Bernardino is interesting due to its size. It is the largest county in California as well as in the United States. Due to its size, there is a lot of variation in the land cover and the land character. To show this variety, let's explore some of the data layers Ryan introduced. To begin, let's start with the PAD-US, which accounts for protected areas in the United States. You'll recall a GAP status of 1 or 2 protects for biodiversity, whereas a status of 3 or 4 does not. A majority of San Bernardino has some level of protection status. However, if we focus on areas with a status of 1 or 2, we see significantly less areas protected for biodiversity. This is not inherently an issue, but let's compare where biodiversity protections are versus where our data indicates they should be. If we turn back on a MOBI layer for species richness, we see there is a hotspot in the southern western portion of San Bernardino. If we compare this to the footprint of our PAD-US GAP 1 or 2, we see there is a disconnect between where we are protecting and where there is species richness worth protecting. Let's look at a different layer, this time one generated using GeoPlanner's Weighted Raster Overlay Modeler tool, or WRO. A WRO allows you to take multiple imagery inputs, weight and score the individual layers and values, and generate a synthesized layer. In this example, our layer is showing habitat suitability. Our model currently is built up with layers for bioclimates, carbon biomass, ecophysiographic diversity, and population, with population having the highest weight. But let's say, for example, we wanted to change the prioritization of our data inputs. To do that, we can change the weights of the individual scores, ensuring that the overall percentages add up to 100%. We could also get into the actual values of the ranges within these layers. When we click Save, our layer updates. With this habitat suitability layer, we are seeing the same pattern of more favorable conditions occurring in the southern western portion of the county, where there are currently no protections for biodiversity. Lastly, let's revisit the intact habitat cores layer introduced by Ryan. While there are cores throughout the county, the best cores align with this reoccurring pattern in the southern western portion of the county. We will now zoom into the Bear Creek watershed, which falls within this hotspot, to investigate how we can improve biodiversity protections to better align with the pattern we just discovered. Our goal will be to protect 30% of the Bear Creek watershed for biodiversity protections, focusing on the intact habitat cores as the assets we want to conserve. Now, as you can see, there are a number of cores within the Bear Creek watershed as options for us to conserve. However, Ryan took us through the process of filtering and ranking these cores to better understand our area. So moving forward, we'll use that layer that he created. And before we turn that on, let's just quickly check in on some of those other data layers we looked at the San Bernardino level. Specifically, I want to compare the PAD-US data layer for any protection status to those that protect for biodiversity. So all of the Bear Creek watershed has a good amount of PAD-US protections, but at the GAP status of 3, so not protecting for biodiversity. We can also turn on that MOBI species richness layer and see that we are really in that hot spot with species richness with these bright yellow areas. And then we can turn on the habitat suitability layer, and we get a little bit of a different resolution here, but overall we can see that we are in a suitable area with the presence of green. But now let's turn on the ranked cores layer that Ryan helped create. So this again goes up to a score of 4, so we can see some good variation here, and we've also lost some of those cores that didn't meet the initial criteria. But we have cores like this with a score of 3.95, 3.88, so there's some good information here about pieces of land that have value for habitat, which should be considered our assets to conserve. We can compare this to the zoning in the area. This is zoning taken from the county of San Bernardino, and you can see that a large amount of this watershed has this green designation, which is for resource conservation. Now, resource conservation in many ways sounds like exactly what we need, but we have learned that these areas have a protection status of GAP 3, and they are not specifically protecting for biodiversity. So for this exercise, what we're really going to look at is how we can upgrade the designation of these resource conservation areas to be specific about protecting for biodiversity. Our goal will be to upgrade at least 30% of the Bear Creek watershed to meet the general 30 by 30 initiative targets that Ryan discussed. We'll use GeoPlanner to manipulate the zoning map and develop several scenarios to achieve this goal. As our next step, before we actually move into designing, we want to take the spatial footprints of this zoning layer and overlay that with the cores layer, so that way we can understand where the actual natural boundaries of these habitat cores relate to the zoning parcel for resource conservation. To do that, we're going to use one of the geoprocessing tools available in GeoPlanner. There are multiple geoprocessing tools you could find in ArcGIS Online, for example, natively found within GeoPlanner. In this case, we're going to use the Overlay Layers tool to run a union between the Bear Creek zoning layer with the Bear Creek cores ranked. The outcome of this is a union that shows the overlay of these geometries. Additionally, all of the attributes from both the cores and the zoning layer have come over, so we can see both the information about the cores when there is a core present, as well as the zoning information such as land use type. This union summarizes the possible candidate areas for protection. In addition to considering the value of the cores, we will also consider the level of threat for each of these areas. One potential threat we discuss for conservation is growing urbanization and development. Understanding population growth is a useful indicator of threat from development. To explore this variable, we will use the tool Enrich Layer. This tool allows you to select variables from a data browser and enrich them onto input feature layers. In this case, we're going to select a variable from the category population. We will use the 2020 to 2025 population growth rate. Once we have this filled out, we can give this output a name and run the layer. The output looks the same, but if we scroll to the end of the attribute table, we can see some new fields have been added on. For this core, the 2020 to 2025 growth rate is 0. This is good because that means that the threat of development is lower. However, for a core over in this area, the growth rate is nearly 0.5%, which indicates a higher level of threat from growing urbanization. Now that we have our cores and our zoning information combined, as well as information about potential threat and the value of our cores, we can move into the designing stage. Because we want to use the outcome of our data exploration and analysis as the units and assets for our designs, we must first import this data layer into our design layer. To do that, we would use the import option underneath the scenario menu. By following this workflow, you are able to take the features of a data layer and bring them over into a design layer. You have the option to assign design types based on a field in your input data layer. In this case, it would be the zoning. You also have the option to bring in fields from your data layer to the design layer. In this case, we would want to carry over the user-defined scores that Ryan created for our cores, as well as the projected growth rate to continue our analysis. In this existing condition scenario, I've already gone ahead and imported our data layer. You can see it looks quite similar, but now we are looking at a design layer. We can see that the land use type, which correlated to our zoning, is appropriately labeled as resource conservation. We can click on other parts and see that this is a residential area in the Big Bear region. And if we click on the lake itself, we can see that it is called a floodway, which is accurately zoned for this lake. So this scenario is specifically focused on existing conditions. I'm going to move into a different scenario called draft scenario, where we will be doing some of our drafting. The scenario menu, again, is where you're able to switch between existing scenarios. Now in this draft scenario, I'm going to move into our design step. Design tools allow you to create new features with specific land use types or change existing land use designations. In this case, we will start with reclassifying existing designations using the Paint Bucket tool. We're going through this process to upgrade the existing generic resource conservation areas to include areas of enhanced protection for biodiversity. We will use the information and data we just reviewed to help us create an improved and data-driven alternative. To better do this, I'm going to turn back on that Bear Creek cores ranked layer and ensure that we can see the scores of these layers coming through to our design. Now I'm going to go ahead and make sure Biodiversity Protections is selected and start coming in and identifying the cores that have the highest ranks. For example, this core over in the southern western region, which has a rank of 3.95 out of 4. This northern core with a score of 3.88. And finally, this lower core that has a score of 3.94. Now, this is a great start, but we aren't actually evaluating any of the design changes that we're making. To help aid us in our design, I'm going to open up the dashboard. The dashboard allows us to understand the performance of our design in real time. The dashboard is comprised of a series of indicators which interpret the square footage as well as attribute information from our designs into a series of metrics. In this example, we have identified a target goal of conserving 30% of the Bear Creek watershed for biodiversity protections. If we come over to this indicator, labeled Bear Creek 30 by 30 target, we can see that currently our design is conserving 20% of our area for biodiversity protections. If I open up this indicator, we can see that the way this is being calculated is taking the acreage specifically for biodiversity protections and dividing it by the total area of the Bear Creek watershed. This tells us that we need to conserve at least 10% more of the watershed for biodiversity protections. I'll dock my dashboard at the bottom of the screen so I can reference it as I move forward with my design. Before I switch over to a different tactic for design, I'm going to paint bucket a few more cores, namely this upper one with 3.81. You can see the dashboard update another percentage. I want to better understand areas that I can prioritize using now the pencil tool, which will allow me to freehand draw new designs. Before I move into this, I'm going to turn on another data layer so I have a little bit more context for my design. Specifically, I'll turn back on the species richness layer. If I momentarily turn off the cores layer and my land use layer, I can again remind myself that there is a hotspot in this eastern portion of the watershed, as well as the northern area. I can put back on my land use and lower the transparency so that way I have a bit better time viewing my design. If I come to the freehand pencil, I can draw in some biodiversity protection in that area that I saw as a hotspot. We have only 4% more to go to meet our 30% target. Perhaps I want to fill in this region that has very few protections. Or maybe you try connecting the overall cores to try to help with fragmentation of our natural assets. You'll remember Ryan stressed the importance of landscape connectivity. So by connecting these two cores in the southern watershed, we're trying to combat that issue. So at this point, we could consider this scenario complete. We've successfully met our goal of hitting a 30% conservation target. So what can we do next? I've created a series of other scenarios which explore different ways that we can aim to meet this target. Let's take a look at them now. If we take a look at proposed scenario 1, you can see a similar layout of cores, but not quite as much as we're not meeting that 30% target. Into scenario 3, we can see a very different layout of our design. Here, we're not even close to meeting that 30% target, and we have large patches of industrial areas throughout the cores. Lastly, we could come back to our existing conditions to remind ourselves there was no protection for biodiversity. A more effective way to compare these scenarios would be through an evaluation tool called the KPI report. The KPI report allows you to select scenarios from your project and get a report that summarizes all of the values from the indicators in your dashboard. Here we have the Bear Creek 30% target, where we can compare which scenarios met or did not meet the needs, as well as some other indicators, one for total acreage of biodiversity protection, one that looks at the protected cores average score as defined by Ryan, and another looking at the average growth rate of the developed land. Now this can be downloaded or shared further with stakeholders or executives for buy-in into a selected scenario. The KPI report can be a great way to whittle down your options, especially if you're collaborating with multiple team members and you have multiple scenarios to consider. Another way to further refine a scenario once you have selected one or a few candidates is to use the project screening tool. Now, before I move further with my project screening, I'm going to switch to the draft scenario that I want us to analyze. The project screening tool allows you to set up criteria that compares your design layers to data layers and helps flag areas for further consideration. In this use case, we want to understand how our biodiversity protections compare to potential threats. I'm going to turn on a new layer that we will use in our project screening workflow. Bear Creek Roads is a data layer that represents all of the roads and highways that pass through the Bear Creek watershed. Roads are an important piece of infrastructure to consider when planning for conservation. They can indicate growing threats from development as well as disrupt existing habitat cores. Understanding which parts of our biodiversity protection comes within a certain distance of roads will help us to improve our design. So to do this, I'm going to set up a project screening that looks for areas of biodiversity protections that come within a certain distance of these roads. The tool summarizes your criteria and allows you to set a sharing level if you want to share this and have it be a repeated option for folks in your organization or publicly. When the tool finishes running, we get a new data layer that represents where criteria was met in our design. These areas in red represent where biodiversity protections come within 75 feet of roads. This is important information for us to come back and review. It might be that we have to add a new designation that is biodiversity protections with extra considerations for infrastructure. In this case, let's zoom into this corridor where we see a lot of potential conflicts. Here, rather than having just a typical biodiversity protection designation, we might come in and say that we need to have a specific plan along these corridors. We could also import these features in order to trace them exactly, or we can roughly partition out areas that need special consideration. Once we're happy with the changes we have made to our design based on our threats, a logical next step might be sharing our project, which we can do by inviting collaborators into our project. We can also share our designs through reports, maps, and other ArcGIS products. Using GeoPlanner in combination with the Green Infrastructure and Living Atlas resources showcased by Ryan, we explored how we could move through a conservation planning process. We set our goals, reviewed data, and mapped assets to conserve. We made sure to assess risk and opportunity and developed alternative scenarios to best meet our goals. At the end of this, we have a scenario that we can begin to share and move towards taking action and implementing. As you take this back to your individual work, think about how data-driven analysis, design, and evaluation can better improve our conservation planning processes. If you're interested in more resources, feel free to reach out to Ryan at the below email, or simply search 30 by 30 in the conference agenda to look up our other session. Additionally, feel free to reach out to Ryan or I for more information about GeoPlanner, and be sure to check out these GeoPlanner resources to get started on your own project work. Lastly, we would love to continue the conversation with you. If you'd like to connect, please feel free to click on the below presenter additional expert tiles to schedule a meeting or chat more with us. From both Ryan and myself, thank you so much, and we hope you enjoy the rest of your conference.